Arterial blood pressure is recorded as two numbers expressed as systolic over diastolic pressure. For example, 120 millimeters of mercury over 80 millimeters of mercury. Systolic pressure, which is seen while the heart is contracting during systole, is the top number. Diastolic pressure, which is seen while the heart is relaxing during diastole, is the bottom number. Arterial blood pressure is pulsatile, and it rises and falls with periods of systole and diastole in the heart. Due to this fluctuation, it is common to calculate the mean arterial pressure, which is what we will examine next. Mean arterial pressure represents the average pressure in the arteries, taking both systolic and diastolic pressure into account. Mean arterial pressure is equal to systolic minus diastolic pressure divided by 3, and then adding diastolic pressure back to that. It is still a pressure, so it is expressed in units of millimeters of mercury. If mean arterial blood pressure becomes too low, for instance below 60 millimeters of mercury, both ischemia and hypoxia can result. Ischemia is the term for insufficient blood flow to the tissues, which creates hypoxia, which is low oxygen delivery to those tissues. Next, we will explore some example calculations of mean arterial pressure. The equation for mean arterial pressure is expressed as systolic minus diastolic divided by 3, and then we add diastolic back to that. Taking typical systolic and diastolic blood pressures as our numbers, we insert 120 millimeters of mercury as the systolic pressure and 80 millimeters of mercury as the diastolic pressure. First, from the left side of the equation in the parentheses, we subtract 80 from 120, getting 40 as a result. We then divide 40 millimeters of mercury by 3, obtaining 13.3 millimeters of mercury. And finally, we add the diastolic pressure of 80 millimeters of mercury back to it, giving us a mean arterial pressure of 93.3 millimeters of mercury. A quick way to check your calculation is to see that the mean arterial pressure is higher than the diastolic pressure that we put into the equation, but lower than the systolic pressure that we put into the equation.